Okay, so welcome back. Yeah, so let's go ahead and resize our devices. So heads up, we'll have to do some calculations, just simple arithmetic. Okay, so briefly to explain. So how do we do that? So we'd have to come here and let me open this device up. So you can see the name, the length, the width. You have NF and you have M. NF means number of fingers and M means multiplicity. NF and NF and multiplicity do similar. What they do is similar, but quite different. Like they do similar thing, but in different ways. So what we want to do about resizing the devices into equivalent devices with shorter width, but with more components. To do that, we can either use NF or multiplicity to achieve it, but it's just that they achieve that same thing in different ways. Before we go ahead to change to give, so we can either choose to use NF or multiplicity, either. But before we go ahead using either of them, I would just like to explain a little more about the idea behind multiplicity, or the physics behind behind multiplicity, or the NF, that's the number of finger. So here we are again. This the book by Professor Tony Chan, I think currently in I think University of Toronto. Yeah, so look at the device, like a single device with a width of 240 and a length of a width of twice the minimum length. For simplicity, let's just say I'm coming. So for simplicity, let's say the width. This just means the width is 240 times the minimum length of the technology you're using, and the length is twice the minimum length of the technology you're using. So let's just eliminate the length. So let's just say the width is 240 for simplicity, and let's say the length of this device is 2. With multiplicity, with the concept of multiplicity or a number of fingers, you can have something like this. They are equivalent, so you can split this device. So from what they did here, they made the length 16 and kept, again, like I said, most times you just want to vary, the width, I mean the width, they made the width 16. So most times, like I said, we just want to vary the width, not the length. We just want to leave the length constant like that. So the width, again, for simplicity, ignore this L mean, just say this W and this L. So for most times we just want to vary the width, not the length. So you can see the length remained unchanged, 2 and 2, but the width changed. So let's say you want instead of you want a single device with a width of 240. This concept is saying you can have a device, you can have a width of 16, and then you have 15 devices to make up for that, and which makes sense. So if you don't want a width of 240, maybe you want a width of 16. So all you just need to do is 240 divided by 16. So it means you need 15 devices to make up for that same width as this former device. So that's the idea behind multiplicity and number of fingers, you get. So that's what we have here. So now let's now go ahead to see how multiplicity and the number of fingers can usually achieve that this. Let me start with multiplicity, which is the easiest. Like, it's just straightforward for multiplicity. So for this we have, right, for the width we have 22.4. so let's say we just want the width to be, let's say 10, or for ease, let's say we want the width to be 11. So all we just need to do is I come here, I do multiplicity. So 11, that is, you want the width to be 11, so 11 divided by 22.4 divided by 11 would be 2.03. so that's approximately, we're talking about that 2, right? Or better still, you can instead to cater for that decimal part remaining, the remaining fraction, we can say 22.4 divided by 11.4. so let's say 11.4, or no, 11.4 is not working. I'm trying to see what will give us exactly 2. So let me just divide. So since I want to divide it, okay, so 11.2, sorry, not 11, yeah, 11.2. so 11.2. so let's say we want a width of 11.2 instead of 22. 11.2 instead of 22. So when you do the division, you get 2, right? So it means you make the multiplicity 2, right? Then you make now the new device. Each of them, they are 11.2 micrometers wide. So what we've done in terms of the device physics of this, we've not, or in terms of the performance of this device, we've not changed anything. Nothing would be affected. That would not that would not change the behavior. In fact, they are equivalent, you get, but the geometry has been changed, but the geometry is equivalent. So again, to just explain that, instead of, if 22.4 is too large, you can, and maybe what you want, it's around 11, so let's say 11.2, all you just need to do is divide the 22.4 by 11.2 and you get 2. So the answer, you get 2. That tells you the amount of device. Anyhow you want to do it, maybe you have a fixed number of devices in mind already, maybe you don't want to go more than beyond 4 devices, so you can do 22.4 divided by 4, then whatever you get, that's 22.4 divided by 4, whatever you get, that's 5.6. that means that will be the new width of the new parallel devices, you get. But for me, I think I just want to go with 2 devices. Since I want to go with 2 devices, I'll divide the original width 22.4 by 2 and I'll get 11.2. so they are equivalent. So performance, they would perform similar way. I've not changed anything. So now let's now go to the CMOS, or should I all at once? First, now that's how multiplicity works. Let's see how let me return it back. Let's see how number of fingers work. So number of fingers, so I've returned everything back to the original form, how it was before. So at the beginning, I want to make use of number of fingers, and mind you, when I was making use of M multiplicity, I wasn't touching the NF. I just left it that way to avoid some it's been complicated, I know. So yeah, then let's say for the NF, I want to make use of NF. So what I'll do, NF work in a different way, and this is how NF works. Come in, let me just check. time. Okay, still 10 minutes. Okay, so quickly for NF, this is how NF works. For NF, you would not touch the width, you would not edit it. Unlike multiplicity, you edited the width and the multiplicity together. You would not touch the width, you just leave it that way. So you would then ask yourself, okay, how many fingers do you want? How many fingers do you want? That is, how many devices do you want? So okay, let's say I want 2. So and so that's all you're going to do. So for you don't need to split the width by yourself. So the software itself would help you split the width. So NF, it's like still the same way multiplicity works, similar way multiplicity works, but instead of you like explicitly sizing everything yourself, you specify, oh, each width, okay, I want 2 devices, that's for multiplicity, 2 devices. Then you now change the total width, you split it equally, you get. But NF, all you do for NF, just only specify the number of fingers you want, then leave the width that way. Then the system will do the division for you. So that is, by the time you export it to your layout interface, that's your magic tool, you would now be seeing 2 devices, and when you measure the width, you would see that the width would have been 11.2. you get. So more of like NF saves you the calculation, the whole stress of the calculation. Okay, just you specify how many devices you want, and you don't care what the eventual width would be, just go like that, you get. But you use multiplicity when you are still bothered what the total width would be, you get. And for our case, I think that would be, well, that's what we want, because remember, I need something. Let me quickly go back. I need something that at least I would be able to capture, like I would see, I want it to be that a single device, I can see everything in just a without scrolling left, right, with just a single screen view. I can just capture one device, like I can just see one device, you get. Though that's not usually a good reason, that's not usually why we want to split the devices and all. It's usually for the size area, the area of the chip, you get. For bigger device, for bigger design, bigger amplifier, or bigger design, analog design, you'd see that you would have more devices, and also with that the size of the chip comes to mind. So but being that this is still small, we really are not bothering about that. Even if I do go ahead and do the design this way with this long, there's really no problem. I don't think it will even be significant in the size of the chip, but we're just trying to observe normal practices, you get. So but for me, I'm taking it for granted. I'm just saying my own reason why I want to split the devices is that I just want to be able to see each of these devices at least in a single screen view, you get. So, and I was like, okay, if this total width here is 22, 11 would not be bad. Half of it, 11, would not be bad, because half of it would just be from here to about this point. So that's why I'm going for 11. So the same way, so if I do 11 for this 11, I should be able to view, you get. So I may want to just go for using multiplicity, where, because I'm bothered about the final width. If I use NF now, like NF, so let's say if let's say I use NF for this NF, I'll just specify I want, let's say 5. What of if, so at the end of the day, what of if 85.6 divided by 5, it's more than the 11 I want? Okay, I think the answer is 17.12. So 17.12 is a little bigger than what I want, so it may go off like the screen, like you get. So maybe you may just want to use multiplicity so that you can just you specify the width, the smaller width you want, then the number of devices come up. But again, sometimes you don't want too many devices, because if you have too much parallel devices, like you can see, you have much connections to make, and all. Maybe you want to save yourself from that. So at the end of the day, it's just trade-offs, like you need to deal with. Even myself right now, I have not made up my mind which I'm going to use, but eventually we would have to choose which we want. But I'm just trying to explain the different concepts, what they all mean. So let me just return this back. So 8511, let me just return everything back to the normal how things were. So what should we do? What do you guys think? Should I make use of multiplicity, or I should make use of NF? So in the next video I would have made up my mind of what to use. So let's continue from there, and yeah, okay, so see you in the next video.